Uh, can you hear me? This anyone?
Yes, we can hear you.
Okay, fantastic. Because something happened. I was getting error message. Okay, so what I'm interested in doing today is to just see if I can do some of the tasks that we had done in Autodoc Tools. If we can use maybe the command line to do those. Okay, and so I'm just going to go with putty onto uh, carbon. And okay, so now I'm on carbon, and I can see I've got some ligands here, and I've got some receptors. And so let me just make a directory called docking, and that's where I'm going to work. And what I would like is if I can, I want to copy that the ligand that I've got, xtb.pdb. This is my ligand as a PDB. I'm going to copy it into the docking folder. And I'm going to copy from the receptor folder the 5rec a.pdb into the docking. Okay. So what I've done is I'm trying to create a new folder that's only got 2 things in. And those 2 things are the receptor and the ligand. And so when I change into that directory called docking, you can do this, all of this in WinSCP as well. You can copy things and move things. I've got a folder that has only 2 things in it. It has got a protein and it has got a ligand. So the first thing I need to do is I need to see these modules at the top here. I just need to check that for docking, you need to make sure that you've got MGL tools, okay? And you also need to make sure that you've got Autodoc and Viner. So these 2 are what we need to have available to us. And then we are all good to go on molecular docking on the cluster. Okay, so let's see what I can do. So firstly of all, I'm going to just have a look at, we know 5-REC quite well. And so what I want to do is I just want to remove all molecules and all waters and clean it up. And so I do prepare receptor 4 minus R, and it's 5-rec. And it's 5-rec A. That's the A conformation that we had from yesterday at that receptor. But the cleanups that I want to do, I want to sort out the hydrogens. I also want to do stuff with the waters, remove the waters. And I also want to remove other molecules from it as well. And what I can do as well is you can also set what your output name is. And I'm going to call it 5-rec underscore A underscore apo.pdbqt. So what this does, this prepare receptor 4, takes as input the A conformation we had that has all the orders, that has a co-crystallized ligand, etc. And the output is 5-rec A. So I wanted to remove all non-standard residues as well, and the output is an apo PDBQT. So what you see in one step is it's removed 4 DMS molecules, and it's removed the co-crystallized ligand, and it's removed the water. And if I do a listing, a directory listing, ls, you can see I now have available to me Okay, the output is a PDBQT. I want it called APO, so something's happened that I don't like, and I'm going to just move it. I want to rename it. I'm going to move 5rec A. It ignored my output. I think I might need to put -O somewhere else. So you see this here? That might need to be at a different point. But I might need to have had that earlier before the -A for it to work, but it didn't create it as that correct name. It's created it without the APO. So what I'm just going to do is a move command, that move a.pdbqt to what I wanted it to be, which is 5rec underscore a underscore apo.pdbqt. Okay, so the command didn't quite work as I wanted it to, but we've got the apo pdbqt ready. So we've sorted out the protein, but what we haven't done is we haven't sort out the ligand. So to sort out the ligand here, here's the ligand. What I'm going to do is prepare ligand for .py, and it's -L for ligand, and I've typed in the name of a ligand, and that's set up the torsions for the ligand. It's set up everything. We've got everything is now organized for the ligand. And when you ls and have a look at that, you can see that I've got a PDBQT for the apoprotein, and I've got a PDBQT for the ligand. So this is performing many of the tasks that you can do by clicking in Autodoc tools, and you can do it directly on the cluster simply by typing those in. Okay. Right. So what do we need to do next? Is that we need to then get a grid file going, and so the grid file. Let's see. So the grid file. What we can do for the grid file is we do prepare, and it's a grid parameter file, gpf4.py, and what that needs is it needs to know what the ligand is. So -L, and the ligand is, here it is, here's the PDBQT of the ligand. It needs to know what the receptor is, and so we need to tell it what the receptor is. And then you can tell it a whole lot of other things. So the one I would like to do is the parameters, and I'm going to do grid center. Please type this exactly correctly. Grid center is equal to, and it's a single inverted comma that you have. And I'm just on my other screen, I'm remembering what we had yesterday. We had 23.0 was the first coordinate, and then comma. The y was 15.0 and the z was 4.5. So there is a grid center that we're going to be using for this system. And all we need now is to have an output. So it tells it where the grid center is, and the output, I'm going to call it 5rec redocking dot. This is a grid parameter file. Okay, and so that has sorted out our grid for us. Now all we have to do is we have to run autogrid. And the autogrid parameter file is 5rec redocking. The one we've just created now is that 5rec redocking is a grid parameter file. So there it is. And -L for log file. And it's going to be the same name again, but we call it GLG for the grid log. So if you type autogrid -p, input is the 5rec redocking, log file is 5rec redocking.glg. This runs autogrid on the server. Sorry, please, it's AutoGrid 4 that you type, not AutoGrid alone. It's AutoGrid 4. And when you run that, if there are no error messages, and it takes a while for your command prompt to come back, for the prompt to come back, you can see the prompt hasn't come back. There, it's finally come back, and then you know it has run nicely. And if you list now, you can see it has created all those maps. There's several maps that have been created for me, which means that we are good to go in terms with the docking. Okay, so the next stage is that we need to run, we need to do the docking itself. And so what I'm going to do is I'm going to do prepare the DPF42. And of course, we tell it what the ligand is. The ligand is, where is it? There's my PBQT for the ligand. There's the ligand, but PBQT. The receptor, let's see if I can find my receptor, is the 5-rec-apo.PBQT. There we go. There's the ligand, there's the receptor, and then we can just go -O. Let's go 5-rec redocking. I need to give it a new name, docking parameter file. Okay. So this name can be whatever you want because it's been created. These have to be exact what's there. The 5-rec ligand xdb.pbqt has to be exactly what I've got in my directory. This has to be exactly what I've got in my directory. The output can be whatever name you like, but please put a DPF at the end to indicate that it's a docking parameter file. And then you can see, if I type less of that docking parameter, you can see how it's been created. Let's have a look in it. And you can see in it, this is interesting. The default it's set is 10 GA runs, etc. You could edit those, but it tells us what the ligand is, what the small molecule is. It tells us the maps that are being created, and those are all that are going to be used in the docking. So I'm typing a Q now to get out of the less. So we're all good to do the docking, and all you have to do now is you type autodoc doc 4, and the parameter file is this parameter file that we've got. Docking DPF is docking parameter file, and the log file is DLG, docking log, DLG. So -P that, -L for log that, and that will then run autodoc 4 for you. And of course, you have to wait quite a while because the poor carbon is busy running this run for you. And so it's going to take a while for it to work. So just give it a couple of moments to work. But there is another way we can work it. And the other way we can work it is using a script that I've got called sub-autodoc. Let's give it a moment or two to do that. Any questions while we wait? Any questions?
We have a question from Andy in the chat, Prof.
Yeah, what's the question?
He says, how do we edit the runs?
How do you edit the runs? Well, you can do it from WinSCP. So do you want to edit the number of runs? So
yes,
this is how I would do it. Let's go to WinSCP. So before I run, have a look here. So it's in docking here, and I'm looking for the docking parameter file. You can simply, in WinSCP, you can right click on the docking parameter file and go edit. And then you can simply just scroll down to that GA runs. I'm going to make it 100 and save. Does that answer the question? Is that what you're asking?
Yes, Prof.
Okay, perfect. So you can easily do that. Okay, so just one thing you can do, the docking log file, it's fine to edit, just don't save it. You can see the progress of a run. We asked for 10 runs, and it's on 8 of 10, so it's nearly done. So please just be patient just for a moment or two. Okay. Right, so it's nearly done. So let's close it, and please don't save when you open the output if something's running. Let's go to the bottom. It's on 10 of 10, so it's nearly done. Okay, and let's just edit now. It is done. So I do want to have a look at it. But what I want you to do is I want you to scroll through the docking that we've just done. We just did 10. Have a look here. Here's the clustering histogram. And that doesn't actually look too bad. See that clustering histogram? We've got 3 clusters, and many of them are in the lowest energy cluster. So it does seem that this docking is quite reproducible, even with only 10. If I'd done 100, maybe we would have like 80 and just a couple in other poses. So this is very reproducible, even with 10. So I'm really happy with the result that we've got. Okay. Right, but one thing I want to tell you is, yes, what I've had to do now is I've had to wait. I'm using carbon to do the running. I'm not using the power of a cluster to do that running. What could I do to use the power of a cluster? And so to use the power of a cluster to do that docking, what you do is you first do QStat to check what queue is free. And I see the del queue has hardly anything on it. But what you can do for that docking is you can go sub auto dock. Okay. And then it's to the del queue that we want to do it. And for the parameter file, just don't tell it the DPF. Just give it the name, but without the docking parameter file. Look for that docking parameter file. And the final thing that you need to put at the end is a 1, because Autodoc, you can only use one processor, which means that if you submit 8 runs, one of these nodes will take that run and do 8 separate runs all at once. When you do that, that's the way you can do it. QStat will then tell you that the docking is running on that. So I'm redoing the docking, but I'm showing you how to redo it without actually typing it in. You can do sub autodoc instead. So if you got a quick run to run quickly and you're prepared to wait, you can do that. But if you don't have a quick run, if it's a long docking experiment, you can always sub autodoc to whichever queue, the name of your DPF, excluding the DPF extension, and just specify it's one core that you're using for it, which means that the cluster knows it can run 8 of those docking experiments on one node all at once. And of course, if you do the sub autodoc, you can log out and it's fine. If you run autodoc directly, you're going to have to wait for it to finish. Okay. Any questions before I sign off?
How do we use Viner, Prof?
We'll deal with Viner tomorrow. But Viner is straightforward because we've already done some of the tasks for Viner now. Remember, right at the stop, we did prepare receptor. That's what you're going to have to do first for Viner. You do have to prepare the receptor. You do have to prepare the ligand for Viner. But what we're left with Viner is we need to edit a file for Viner. that has those names in it. And then we'll be able to submit a Viner file. Okay. So I'll show you tomorrow how to do that.
Okay, and one last thing.
Yes.
So when we download our ligands from Zinc, do we still have to optimize them, or are they already optimized?
Big problem. Yeah. And you see, it's zinc.docking.org. Okay. And those are prepared for docking. So you don't really have to optimize them. But I've had two purposes in showing you how to use a QM optimization. One is that QM optimization that you've done before is very versatile in other situations. And the second thing is that you may get ligands from somewhere else than zinc, somewhere other than zinc, that don't have that do not have the quality that zinc has. In which case, I prefer you to take those all through XDB. So if you take the zinc ones and you re-optimize them in XDB, that's fine. That's good. They were good to start off with. They'll be good at the end. That's fine. But with zinc, those ligands, the 3D structures you get from zinc, are designed to go straight into molecular docking. Any other questions? Okay. Please, as usual, just email me, send emails to me, and I will respond as best I can. And of course, as you see, it does help if we share screens. So if you tomorrow would like to share your screen in front of the class, it's going to help other people because other people will have the same problem that you have. Okay.